Hey, hello and welcome to 7.8. So this is going to be the last and final section for this chapter that we need to cover. It's called recursive formulas, which is basically like a formula for our sequence, but it's repetitive. So it's going to be written a little bit differently. So we've written formulas before. The ones we did we call explicit because it's written exactly as you would expect. For both when you add and subtract, that's arithmetic, and for when you multiply and divide. Now we're going to use these recursive formulas to write our sequences. So how about a first example? They ask us to find the first 5 terms of the sequence where the first term is -8, and any term can be found by taking -2 times the previous term plus 5 if you're starting at the second term or beyond. So find the next 5 terms. We could do it. So we already know the first term is -8. They tell us that right there. So this first term is already given. And now we can use our formula to find the rest. So if we wanted to find the second term, or a sub 2, that will be -2 times a sub 2 minus 1 plus 5. So what does this a sub 2 minus 1 mean? Well, that's a sub, 2 minus 1 is 1. So a sub 1 is just the first term. So this whole phrase here means the same thing as a sub 1, which we know, based on what was given, is -8. So this whole phrase, a sub 2 minus 1, is the same thing as -8. So we can plug that in right here. And now we can solve for our second term really easily. -2 times -8 plus 5. Multiply these, you get a positive 16 because negative times a negative is a positive. Add 5, you get 21. So 21 is term number 2. Now you can find term number 3. So -2 times a sub 3 minus 1. A sub 3 minus 1 is another way of saying a sub 2 because 3 minus 1 is 2. And what is a sub 2? Well, our second term was 21. So this whole phrase is another way of saying 21. So we can take -2 times 21 and then add 5. So -2 times 21 is a -42. Plus 5 would give us -37. So there's our third term. And we can continue in the same logic to find the first 5 terms. So when you're asked to do that, you start from the beginning, a sub 1, work your way all the way through till you get to the 5th and final term that you need. So you start at the beginning, work your way through. So we have second term is 21, third term, -37. So same logic, keep going. So we have same rule, but now we see we're putting in a 4 to find the fourth term. So a sub 4 minus 1 is the same thing as a sub 3, which we saw based on our previous example was -37. So where we see a sub 4 minus 1, this means the same thing as -37. So you have -2 times -37, that was the previous term, plus 5. What does that look like? -2 times this plus 5. Here you get a really big positive number, that would be positive 74. And then add 5, you get 79. So there's our fourth term, term number 4. Now we need one more, we need the fifth term. So fifth term equal to -2 times a sub 5 minus 1. This is another way of saying the fourth term, which we just found to be 79. So here, this is the same thing as 79. You can see we're dependent on the previous term to solve for our next term. So -2 times 79 plus 5 What is that? You can put this in a calculator. You get negative 158 plus 5 is negative 153. So there's term number 5. And now you have the complete list that you needed. So term number 1 was negative 8. So we can label these. We already know this, but term 1, a sub 1 is negative 8. Term 2 was 21, that's a positive. Term 3 was negative 37. The fourth term was a positive 79 that we just found. And our fifth term, or a sub 5, was a negative 153. So there's everything you need on example 1A. Great, so let's look now at 1B. Similar example. They ask us to find the first 5 terms of this sequence when the first term is a negative 3. So here we see first term is a negative 3. Right away I'm looking at my answers. C is wrong because it starts with a negative 12. That's not right. D is wrong because it starts with a negative 21. So those two are already gone. So let's look at our rule. It says take your term is equal to 4 times the previous term minus 9. So let me plug in, if I wanted to find the second term, let's do this one in red. If I wanted to find my second term is a sub 2, that will be equal to 4 times a sub 2 minus 1 minus 9. So I just put in a 2 where there was an n on both sides of the equation. That was all I did. Now, second term will be equal to 4 times a sub 2 minus 1 is the same thing as a sub 1 minus 9. Great. Now, a sub 1 is something that we know. So a sub 1 means the first term, and we already know what that is. It's negative 3. They gave it to us in the beginning. So this is 4 times a negative 3. So I'm going to plug that in my next step. So my second term must be equal to 4 times a negative 3, take away 9. Now we just need to follow order of operations. So multiply before we subtract. So second term equal to negative 12 minus 9. So my second term is equal to negative 21. Now if we look at our options and our answer choices, we actually don't need to do any more work because option B has negative 21 for our second term. But the second term in option A is a negative 12. So we know that has to be wrong. So there's only one thing left. That is option B. Based on our rule, we can clearly say our sequence must be negative 3, 21, 93, 381, yada yada, and so on. So for 1B, we confirm letter choice B. Following our rule, we can find any term we want. We're only asked for the first 5, but you actually only need the first 2 to get your answer. So 1B, option B is correct. So here's the rules that we already talked about for recursive formulas. If it is arithmetic, we use this rule. Looks like that. If it is geometric, we use this rule. Looks like that. So either one, depending on the case. So 2A, write a recursive formula for the sequence. So first, what kind of formula are we looking at? Is there a common difference or a common multiplier? Well, if you want to know if there's a common difference, are we adding something the same every time? Well, you can clearly see if I add 6, I get 29. If I add 6 again, I get 35. One more time, I get 41. So we're adding 6 every time. The common difference is 6. So the sequence is arithmetic. We've already worked through that a lot, so that is not new. This is an arithmetic sequence. We're adding 6 every time. Hopefully that is clear to everybody when you're looking for a pattern. It can be through addition or subtraction, that would be arithmetic. Or it can be through multiplication, that would be geometric. So this one is arithmetic. So we're going to use the formula for an arithmetic sequence. Looks like this. We already have that on the board and in our notes. So now that we have that, we need to plug in what we need to get our formula. So what is our common difference? So this D piece, we already know. Our common difference is 6, and it's positive. So where the D is in our equation, we'll put a positive 6. Fill that in. Now that we have that, we can do the rest. So our first term, a sub 1, is 23. So our recursive formula would look like this. Our first term is 23. Our first term is 23. And any term can be found by taking the previous term and adding 6. So this is our rule that we had. And the only thing we needed to add to it was substituting in our common difference. Our common difference was 6. So we put that in, and now we have our formula as great as it needs to be. A sub n equals the previous term, a sub n minus 1, plus 6. Now we're done. So how about 2b? We're asked to write a recursive formula for this sequence. Notice that it is alternating positive and negative signs. So whenever your formula or your sequence is alternating signs, you know it needs to be a geometric sequence. If there's a multiplier that is negative, that's the only way you would have it alternate positive and negative like that. So we can already start to think that it's going to be geometric. So what would you need to multiply by to get it to be alternating like this? Well, 7 to 21 would be 3. 21 to 63 would be 3. And 63 to 189, you can check, would also be 3. So there's no common difference by adding, but if you were to divide each term by the previous one, you see the common difference, or the common ratio is negative 3 every time. So we're multiplying by negative 3 to get to one term to the next. We've already talked through that a lot. So this sequence is going to be geometric. Geometric sequence. So now that we know it's geometric, that cues us into which formula we need to use. These are on the board, so you can tell that you need the geometric sequence. Looks like this. Great. So now that we have that, we plug in the thing we need to know. What is R? What is our common difference? Well, the good news is we've already found that, so we can just plug that in. We already said our common difference was negative 3. That is our multiplier. That is our common ratio that we use to get from one term to the next. So plug that in. And now this becomes our rule. The first term is a sub 1. We say in this one it was 7. And we always say n has to be greater than or equal to 2 for these recursive formulas. So our answer tells us then any term a sub n can be found by taking negative 3 times the previous term and that will get us to where we need to go. That will tell us our recursive formula. So this positive 6, we don't need the positive 6, but it should be any term equal to negative 3 times the previous term, and that is our rule. You see that already written right here. This is what we need for our geometric sequence. Just plug in R, and then the rest is good to go. Okay, how about a 3A example? So for this one, you're going to need the chart here. So just those 4 rows going for the price and the year. So they tell us the price of a car depreciates at the end of each year. Let's write a recursive formula for the sequence. So we need to know what is the first term and then what is the ratio, what is the comparison from one term to the next. So we can subtract these price values, take one, subtract the previous one, and see if there's a common difference. But you can already tell there's not a common difference. To get from 12 to 7,000 would be 5,000. To get from 7 to 4 would be 3,000. To To get from 4 to 2 would be 2,000. So clearly the addition is not the same. But is there a common multiplier? Is there a common fraction that we could multiply by? To find that, you'd have to take one term and divide by the previous one and then compare them. So there is no common difference. We already said that. But if you were to take one term and divide by the previous term, you get 3/5. If you take the next term and divide by the previous term, you still get 3/5. Take the last term, divide by the term before that, still get 3/5. One more time. So there is a common ratio, and it is 3/5. So this sequence is geometric, and that is because there is a common multiplier. Geometric. So, since that is true, we will use the geometric formula, which you now know. Looks like that. And now we need to plug in one thing and one thing only. What is R? What is our common difference? Well, good news, we already found it. It is 3/5. So 3/5 needs to go here in our formula. Plug that in, and then we have everything we need for this problem. Any term can be found by taking 3/5 times the previous term. And that is our formula. So that will conclude our answer. Now we also want to throw in here what is the first term, so it's 12,000. And our other factor that we need to include is that we only want to talk about term 2 and beyond, not the first term. Because you can't take a sub 0, so we need this to always be either a 2 or bigger when we plug in here. But there's our rule using our ratio and everything else we said. So we'll use those steps as we go to practice today and solve these problems.